Okay, remember when we had to find the inverse of these? It was 1 over the determinant, and then we switched the order around. So A and D switched, so that would have been an 8 and a 1. They would have switched around, and then these signs changed, so that would have been a -10 and a +2. So we'd have to find the determinant first. Okay, well the determinant is 1 times 8 minus -2 times 10. So 8 minus -20, so 28. So it was 1 over 28 times all of this. And we were answering it like that, or you could have gone ahead and multiplied it in. So it would have been 8 28ths, -10 28ths, 2 28ths, and 1 28ths, which we would have reduced to, let's see, 4 goes in there, 2. So 2 sevenths, -5 14ths, 1 14ths, and 1 28ths. So that would have been the inverse. If we take this thing times this thing, we get the identity matrix. We would get 1 0 0 1 like that. Okay, well our calculator will help us with this now. Let's just go put that in. Second matrix, edit A. Now I need it back to a 2 by 2. 1, 10, -2, 8. So I got it in. So I can get the determinant of that. There's a determinant button. I do second matrix math, determinant of second matrix A. Sure enough, it's 28, just like we said it was. So 1 over 28 was how we get started. Okay, well, you would think that, again, it's just a process. You switch the order of these two, you negate these two and multiply it in. Okay, hit second matrix math. Let's take a look at what else we have. I don't see the word inverse anywhere. Okay, that's because it's not on there. Think about what this button does right here, x to the -1. If I put in a 2 and hit that button, it makes it 0.5, which as a fraction is 1 over 2. If I put in a 3 and hit that -1 power, hit math fraction, gives me 1/3. Because 3 and 1/3 are inverses of one another. They're multiplicative. If you multiply them together, you get the identity of 1. Okay. Well, that button will do that with matrices too. If I get matrix A and I would like the inverse, I'm just going to hit this inverse button right there. We already have a button that's inverse. That's why it's not on the menu. Okay, that does not look like what we got when we did it by hand. Math fraction. Well, sure enough, it is what we got when we did it by hand. If you just clean up those decimals and turn it into something a little bit more clean. See, the calculator already took the 1 over 28, it already switched them around in the right order, and it gives us the inverse. Okay, I'm going to store that. I'm going to push store. Now I'm going to store it in a matrix. I'm going to do second matrix and go down to vary it to B. So I'm going to take this answer and store it into B. Okay, remember I said this one, the inverse times the original should give us the identity. Okay, if I do second matrix B times second matrix A, sure enough, we have the identity. That's a little proof that this does undo that one. Okay, so getting the inverses now are really easy. So go ahead and do number 20. Second matrix, edit. Get a 2 by 2. Okay, we got a 2 by 2. Put in the data. -5, 6, 9, -10. Now, literally, you don't even have to do anything. I'm going to say second matrix A, inverse button. Okay, there it is. I'm going to put that back as a fraction. So 5 halves, 3 halves, 9 fourths, and 5 fourths. That is the inverse. Doing a 3 by 3 was a much bigger deal. Remember, okay, we still had to get the determinant, so it was still the determinant. It was still 1 over the determinant, which was, we probably did the diagonal method and do all that diagonal stuff to get that. But then we had to get this matrix of mini matrices. So I took the 2 and got its mini matrix there. So the 2 spot had a -6, 6, 0, 0. And then we took the -6 and got its mini matrix, crossing those out 6, 0, 6, 0, 0. And we did that for all 9 of them. And then we got the determinant of all 9 of those. And then the row became the first column, the second row became the second column, and the third row became the third column. And we had to do positive, negative, positive, negative, positive, negative, positive, negative, positive. Get all that and multiply it by 1 over a. It was a huge hassle. Ha! Now it's one button. Second matrix, edit. Okay, I need a 3 by 3. I'm going to put in the data. 2, -6, 3, 0, -6, 6, 0, 0, 0. So I can quit. I want second matrix A inverse. Okay, I didn't mean for there to be one already that had no inverse. Okay, darn it, the other one has no inverse either. Okay, well, you can see we have an error. So what ended up happening was probably this became a 0 right there, 1 over 0, and I tried to multiply it together. But right there it even tells you no inverse exists. That means there's nothing that you can multiply back to this one to make the 1, 1, 1, 0, 0, 0, 0, 0, 0 the identity matrix. Okay, I thought I put this one in here to be that. So let's do a different one that I know has an inverse. I think we can leave that. Let's just change this bottom row to 1, 2, 3. I think that will do it. Let's put it in and see. I mean, it's not that hard to fix. Okay, 3 by 3. I'm going to put that in quick. 6, 2, 1, -6, 6, -5, 1, 2, 3. Second matrix inverse. Do we have an inverse? Yes. So I'm going to put that back to fractions. Okay, it's kind of an ugly one. I'm not really going to write that answer down. Okay, yeah, I will. I want you to, so. Okay, so 7 44ths, -1 44ths, -1 11, 13 176, 17 176, 3 22, -9 88, -5 88, and 3 11. Good thing we didn't do that one by hand. That would have probably been a beating. But what I am going to do on my calculator is push store. And I'm going to store that in second matrix B. Because what this is saying is this one is, if I take this one and put it in front, you got to put it in front. The inverse always has to go first. So if I take A inverse and multiply it times A, it should give me identity. Well, let's see. So my A inverse, I just stored it in B. So if I do second matrix B times second matrix A on my calculator, I'm expecting the identity. And then notice the calculator took a second to do it because it had to do, remember what it did? It did row times column, row times column, row times column, and ended up with 1, 0, the identity matrix. So check. That's a little proof. This one does undo the original. Now, what was the point of that? The point of that was to do algebra. This capital X is a matrix. 5 times some matrix, and then if I add this matrix, it gives me this one. Okay, well, I'm going to do algebra. So first I'm going to subtract this one to both sides. So I'm going to subtract those two. So I'm going to subtract it over here. 4, negative 10, negative 6. Okay, that leaves 5x equals, okay, negative 46 minus 4. So that's going to be negative 50. Negative 10 minus negative 10. So negative 10 plus 10, that's 0. 29 minus negative 6. So 29 plus 6 is 35. Now this is scalar. That's a 5 times this one. So I can just divide both sides by 5. And now the matrix that would have made that work, negative 50 divided by 5 would be negative 10. 0 divided by 5 would still be 0. And 35 divided by 5 is 7. Okay, let's use our calculator to see what all of that just did. Okay, I'm going to call this one right here matrix A. I'm going to call this one matrix B, and this one matrix C. Okay? So I'm going to go to second matrix, edit. Now this is a 3 down, 1 over. So 3 by 1. It's 4, negative 10, negative 6. I'm going to go edit B. It's also a 3 down by 1. And it needs a negative 46, a negative 10, and a 29. I'm going to do second matrix, and I'm going to go edit C. It also is a 3 by 1. And it is a negative 10, a 0, and a 7. Okay, this was our answer. I'm just going to set it, I'm going to show us what we've got, what this is happening here. This problem says 5 times some matrix. So 5 times, now we solved it. That matrix is right here. We stored it in C. So if I say 5 times matrix C plus matrix A, the calculator should give me this B answer right here. Negative 46, negative 10, and 29. That's what we were doing. We were solving, we were trying to find a matrix that if we plug it in right there, makes it true. Okay, so let's do that with 24. Now I've got a matrix times another matrix. I'm going to have to do an inverse on this one when I get to it. So it's just like, so it's kind of like this, negative, it's kind of like I've got a 5 minus 3x equals 10. So it's kind of like this is a number minus another number times a variable equals something else. So we would subtract the 5 first. Well, that's what I'm going to do over here. I'm going to subtract this matrix first. I'm doing the additive inverse. So that means I'm going to subtract it over here. So subtract negative 4, 2, 2, negative 1. Okay, well, let's see what that is. 26 subtract 4. So 26 minus 4 is 30. 17 minus 2, 15. Negative 44 minus 2, negative 46. And negative 43 minus negative 1. So negative 43 plus 1, negative 42. Okay, see this negative is still on there. So I'm going to divide both sides by negative 1. That's just a scalar. All right, here's what we got. I've got 0, 3, negative 2, negative 4 times some other matrix equals, and now this negative 1 is just going to make all these the opposite sign. So negative 30, negative 15, negative 46, and negative 42. Whoops, I need to negate, so that's positive 46 and positive 42. Okay, I can't just divide this off like it did the 5 up here. That 5 was just a number. This is a matrix. I have to inverse the matrix. If I call this matrix A, I need A inverse to be multiplied by it. A inverse times A makes it go away. It makes it go to the identity matrix. So I need A inverse. Okay, well, let's get A in the first place. Let's go make A some, so right here, A is a 2 by 2. It's 0, 3, -2, and -4. Okay, there's A. I need A inverse. Now our calculator, it's really nice and quick. A inverse is that. So I have to multiply both sides by that matrix. I'm going to multiply this side by that matrix, and it always has to come in front of what we're doing. So it's the inverse times the regular. That's going to leave x. Okay, I've got to put the inverse over here on this one. It's got to be in front. I've got to put it right here. That A inverse has to go right there. The -2/3, the -1/2, the 1/3, and the 0. It's got to go in the front. I've got to take the inverse times this one. So I did it on the left. I got to do it on the right, and that will do it. So I need this inverse. I need this matrix times this one. Well, I'm going to store this one in B. Alpha matrix number 2, B. Okay, so I have this one in B. I'm going to store this one in C, and then I'll just do B times C. Okay, so second matrix, edit C. C is a 2 by 2, and the numbers are -30, -15, 46, and 42. And now all I need is B times C. So second matrix B times second matrix C. B times C is, the missing unknown matrix was -3, -11, -10, and -5. I'm going to store this one in matrix D for just a second. And go back and see if we can't figure out what it all says. That's this matrix right here. So this one minus this one times this one should equal that. So I already know I have this one stored in D. I'm going to put this one in E and this one in F, just to check it. Okay, so E is a 2 by 2. It needs 0, 3, -2, -4. And F is a 2 by 2, and it needs -4, 2, 2, and -1. So this problem says F minus E times D should equal this one. Well, let's see. Let's put it in. Matrix F minus matrix E times matrix D. That should end up to be 26, 17, -44, -43. That's what we found. We found the missing matrix that makes this true. Okay, 25 and 26, let's hammer those out. So now on 25, I'm just going to add this matrix to both sides. So I have this 2, 8, negative 2, negative 8 times some big matrix is 18 plus negative 4, so that'll be 14. Negative 15 plus 11, so negative 4. Negative 8 plus negative 6, negative 14. And 5 plus negative 1, 4. I just need this. I need the A inverse of this one. And then I'll multiply it over here times this one. Okay, I'm going to put this one in A. It's a 2 by 2. 2, 8, negative 2, negative 8. Okay, got it in. I'm going to put this one in B. Okay, so I have this one is in A. I'm going to put this one in B. Okay, so second matrix, B. 2 by 2. It's 14, negative 4, negative 14, and 4. Okay, so I need A's inverse. So I need to multiply both sides by A inverse. So this is really what I need to type in right there. A's inverse times B. You don't even have to get A's in, you don't even have to look at it. I'm going to here just for a second. There's A's inverse. Oops, I forgot. You can't see it. There's A's inverse. Well, A doesn't have an inverse. Okay, well that means there's no inverse of this matrix. That means there is no solution to this. There's no problem there's no matrix you can put right there to make this answer. Okay, let's do this last one here real quick. This last one does have an answer, so. Okay, I'm going to subtract this matrix to both sides. That'll make those two go away. Okay, this is a negative 4, negative 4, 10, negative 8. So 0 minus negative 4, that's going to be 4. 48 minus 10, 38. Negative 4 plus 4, 0. 30 minus 8, so 30 plus 8, 38. Whoops, I did that wrong. Okay, start over. It's this one we got to subtract. This is the addition one, so those have to subtract. So I need to subtract that over here. Running out of paper now. 2, 0, negative 8, negative 6. Let's try that again. So I've got 0 minus 2. 48 minus 0. Negative 4 minus negative 8. So negative 4 plus 8. And 30 minus 6, so 30 plus 6 is 36. Now I don't like calling this one A because I'm going to call this one A. I'm going to put that in matrix A. So really I'm going to put this one in matrix B. So I'm going to put that in A and that in B. Okay, so I'm going to take a quick second and just do that. Matrix A is a 2 by 2. It's negative 4. So there's matrix A. I'm going to put this one in matrix B. 2 by 2, negative 2, 48. 12 and 36. Okay, so the process is you got to put it to the left. So I need A inverse times this one. That will make this cancel out. That means I got to put A inverse over here times this one. Now this is what I was going to say last time. I could go ahead and look at it, but I don't really care. But there it is. At least this one has one. I need to take that times B. Well, you don't have to store it. You can just say second A inverse times second matrix B. You can just jump right to the answer. A inverse times B is right there. So our missing matrix was 17, 3, 7, negative 6. That, if we stick it right there, if we take this matrix times this matrix and add this matrix, we get this one. And now we have our calculator to make all of this go faster.